Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 105 and the question is 18. It reads, a destroyer is sailing northeast at 20 kilometers an hour. A cruiser appears to an observer on the destroyer to be moving due east at 10 kilometers an hour. Determine the actual direction and magnitude of the velocity of the cruiser. So where do we start? We start, of course, with a sketch. So we draw our y-axis and our x-axis, making our xy or Cartesian plane. Then we draw what we're given. We're told the destroyer is sailing northeast. This would be northeast, like so. So I'm going to say it's at the moment at the origin. It doesn't need to be there, but I'm just going to place it there because it's easy. And this is the actual direction with which the destroyer is sailing. So I'm going to say this is actually the velocity of the destroyer. So if I was, for example, in a helicopter above it, I would see it moving in a northeasterly direction. Which of course means, by the way, that this angle here is 45 degrees. We're also told that to an observer on the destroyer, a cruiser appears to be moving due east. So let's look at this. We could have the following. We could have VDE, or VDC, excuse me, the velocity of the destroyer relative to the cruiser, or we could have the velocity of the cruiser relative to the destroyer. So this is VD minus VC, and this is VC minus VD. And crucially, of course, that means this is in a frame of reference whereby it believes it is stationary, and here it's D that believes it is stationary. Alright, so let's just read the question again. It says, to an observer on the destroyer, the cruiser appears to be moving due east. Alright, so that means that in this case the information we're given corresponds to the point where D is the stationary frame of reference. So D is stationary and it is watching C move. Alright, so that's the scenario we have. So just let me get rid of the piece of information we no longer need. Like so. So we have VCD, and we're told that VCD is equal to due east at 10 kilometers an hour. So its magnitude is equal to 10, and it's going due east. So it's going this direction. Like so. And what do you notice straight away? Excuse me about that, sorry for knocking it. You notice that it has no y component. So it just lives in the x-axis. So it's 0 j hat, we'll say. And what are we asked to do? We're asked to determine the actual direction and magnitude of the cruiser. So let's see what we can do here. So you know VCD, we just said, is equal to 10 I hat, positive 10 I hat, plus 0 j hat. We're told that we need to find out VC, so I'm going to call it x I hat plus y j hat. Just some variables, random variables, or unknowns. And we got to take away from that the velocity of the destroyer. Now look, it's going to be, we just need to resolve this into its x and y components. So it's going to be equal to what? The two vectors which when added together create it, and these vectors must be parallel to the x and y axis. So this is going to be VD sub x I hat, and this is going to be VD sub y j hat. That's going to be equal to VD times the sine of 45, and this is going to be equal to VD times the cosine of 45. That's something which we've done ad nauseum at this stage. By the way, the cos of 45 is equal to 1 over root 2, and so is the sine. So it's basically going to be equal to the magnitude of the destroyer's velocity is equal to 20. So 20 over root 2, so we divide 20 divided by root 2 gives us 10 root 2 or 14. Let's say 10 root 2. So here it's going to be minus 10 root 2 I plus 10 root 2 j. By the way, it's plus plus because it's going in the plus plus quadrant. Alright, so let's just rearrange this. So we get 10 I hat plus 0 j hat is equal to x I hat plus y j hat, negative 10 root 2 I hat, negative 10 root 2 j hat. So this is going to be 20, or no, it won't be 20, no, I can't add the 10s like that. So 10 plus 10 root 2, so it's going to be, we'll say 24 I hat plus 10 root 2 j. is equal to xi hat plus yj hat. Oh, sorry, you couldn't see that. Okay, I'll just leave that there for a moment. Sorry about that now. So all I did basically was just put the negative sign here, bring them across and add them to the two numbers over there. So we need to get we're asked to find the magnitude and direction. So first of all, let's get the magnitude of this vector. It's just going to be a bit of Pythagoras, and we're going to get the square root of 24 squared plus 10 root 2 to be squared. And that turns out to be what? So it's 24 squared plus 10 root 2 squared, all square rooted. And you're going to get the magnitude at approximately 28 units. Alright, that's the magnitude of it. And its direction. So look, it's going to be plus x plus y, so it's going in this direction here like so. Is that correct? Yeah, that's correct. Okay, plus x plus y, so it's going in this direction here like so. So just resolve it again. This is equal to 10 root 2, and this is equal to 24, and this is equal to theta. So if we just get the inverse tan of theta, it's going to be 10 root 2 divided by 24, and press shift tan to get the inverse tan of that. It turns out to be about 30.5 degrees. 30.5 degrees. So let's just check those answers in the back of the book. So on 4B question 18. So east 30 degrees north, yeah, that's correct. And 28 units is also correct. Yeah. So yeah, we're fine. That was pretty straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.